So we have close to 50 people, 49, 50. Okay, we'll start. Okay, good morning everyone. So,
yes, Rohit, we can start.
am I audible? Yeah, okay.
Yes, you are audible.
Okay, just in case if I ask questions, someone just unmute and you can tell me whether it's audible or not. Okay, anyone?
Hello, Rohit.
Yes.
इसका सेशन रिकॉर्ड हो रहा है, राइट?
हाँ, सेशन रिकॉर्ड होगा.
क्योंकि मेरे ना मोस्ट ऑफ द टीम मेंबर्स आर कमिंग इन नाइट शिफ्ट ना, तो
फाइन.
विल शेयर दैट रिकॉर्डिंग टू देम.
नहीं, अभी ऑन नहीं किया. ऑन कर. So we will start. Okay. So looking at the audience, I believe most of you know me.
What is?
For the rest, my name is Rohit Dadve. I am from BIL team, SNOC IPI. I'll be taking you through this basics of our network overview and troubleshooting. Basically, the session when we have earlier discussed, this was arranged for L1 engineers who are working on IP on day-to-day basis. And we have observed there are few basics that are getting missed in between. Okay, so how we will proceed? First, we'll take a quick poll about the audience. Okay, so what is the total number of experience they are working on? So I'll be able to know how many people are working at L1 level, and rest of the people they can guide them again. So those who are at senior level, they might feel that these are very basic, and they might think that why this session is arranged, because these details should be known to everyone. But mainly this session was arranged for the level 1 engineers who may not have a systematic flow of network, who may not know the systematic flow of network, login, OEMs, network faults, and what are the primary checks that we are doing. Okay, so first of all, I'll launch that poll. Those who have joined with laptop, they can see that there is an activity tab. So there is an activity tab. There you can see polls and Q&A. Okay. So when I launch the poll, you can just go and quickly select the number of experience. It will take hardly a few seconds. And then I'll take 2 minutes to review the audience. Okay. And after that, there are few more things that I want you to follow. First of all, mute yourself. If you have any queries in between, just go to this activity tab, put it in Q&A. Since even if you are raising hand, I will not be able to see who has raised hand and who is talking. So we'll take all those questions in the last 15 or 20 minutes. Okay? Just go to, you might have seen that poll tag. Just quickly select, let me know. I hope everyone is aware. Those who have joined from mobile, they can see there are 3 dots. In that 3 dots, once you click, you will see the activities tab.
किती 1 किलो वाटले किती 1 किलो
नाही 1 किलो त्याला 5 किलो आहे वाटतं.
So far we have 58 people, only 28 people have given votes, and I can see maximum people are having more than 5 years of experience. They might feel this session is very basic. Quickly it will take. Okay, you guys can keep on mentioning that. I can see at least 13 to 15 L1 people have joined who have less than 2 years of experience. Okay. We'll move ahead with this presentation. So coming back to agenda. Okay. So this is clearly visible. Okay. So we'll go through, poll is going on. We'll go through the basic network overview. So I have tried to keep it as simple as possible. I'm not going via LLD architecture. I have prepared block diagrams so that you will get an holistic view of network. You will understand which type of networks are there, how we have segregated, and into that domains, how we have subdivided our networks. Okay. Then we will go through what is the login flow. How do we log in into devices, and what is the management flow? When I say management flow, that means how it is connected with ecosystem. Then what are the OEMs like Cisco, Juniper that are connected in V network. Then we will go through the network faults. When I say network faults, it will be purely based for our network related, not service faults. Okay, and at last, we'll see a quick view of CLI. What are the primary checks you should be doing when you are doing fault investigation as an L1 engineer? Okay, so if you have any queries, you can put it in Q&A. I'll review later, and at the end, we can take all those queries at once. Okay, there is a possibility. Right now, you have a question, but I have already answered at the later stage. So that's why keep your questions for the last 15 to 20 minutes. I'll start the recording. Okay.
This call is now being recorded.
I hope you can see the recording tab.
I completely agree with you. Actually, it is coming.
So, as I said earlier, we'll go through basic network overview, login flow, OEMs, network faults, and primary checks of fault investigation as a part of this particular session. At any point of moment, if you think that my voice is not audible, okay, or if you have an absolute query which needs a clarification, you think there is some disconnect what you are doing in day-to-day operations and what I am telling, then you can immediately raise hand or unmute yourself and let me know. Okay, so we'll move ahead. So basically, we are all working in IP domain. There are multiple domains in the SNOC architecture. Okay, you might be aware there is packet core team, there is VoLTE, CS core, transmission, DWDM. We are working in IP domain. And to manage this IP network, we have subdivided these networks into subdomains so that we can manage this network effectively in a systematic way and a scalable way. So what are those subdomains? We have IPSEN network. Okay, IPSEN as in there is no subdivision further. IPSEN network carries your mobility services, 2G, 3G, 4G. Also, there is part of other network connectivity on this IPSEN devices. So IPSEN is further segregated layer-wise into core, aggregation, pre-aggregation, and access. These are the network layers. So those who have taken any basic training of Cisco earlier, or who are getting trained, okay, you might have aware about the network hierarchy. Any network which is designed, it is designed into 3 layers. It is core, distribution, and access. So in our network terminology, we have distributed in core, aggregation, pre-aggregation and access for IPSEN, and core aggregation and access for rest of the domains. There are some setups like Packet Core VGW where we have adopted data center architecture, where we have connected DC gateway, spine, and leaf. We are not going to get into detail about any of this network. All these details are available in LLD. Right now, the purpose is you should be aware how these networks are logically connected with each other. Once you go through day-to-day faults, how you are checking the faults, the protocol layer connectivity, then you will be getting more knowledge about these architecture. So IPSEN we have seen where our mobility is connected. Second is IP core, IPCP and IPDCN. In IP core, we have FLDS, NLD, MSP, NGN and ISP. So one more poll I wanted to take, whether there are people who are not from IP domain, but I have skipped that part. So I'll just quickly brief. FLDS is our fixed line data service network, which earlier was used for only data traffic prior to 3G and 4G services. So this was specifically used in erstwhile Vodafone for data services. In parallel to this FLDS, in erstwhile Idea, it was NLD network. So this network will be soon consolidated and it will be called as National IP Backbone Network. So right now what we are calling FLDS NLD, once consolidated, we will be calling it as NIBN. When Vodafone has acquired cable and wireless, the part of India network was given to Vodafone India. That network is MSP and cable and wireless worldwide. So that few routers that we are managing, this is MSP network. NGN is used for intercore voice traffic and ISP is for internet traffic. Similarly, in IPCP, we have subdivision. We have ILD, all these networks, whatever I have mentioned, we are working on router and switches. So we have ILD, IN network, IT switches, LD, MPBN, NDS, OSS, Packet Core V Gateway, STP, Telco DC, few op setups, and VoLTE. In addition to this entire network, we had in erstwhile Vodafone a management network called DCN. This network is divided into two, Circle DCN and National DCN. So the architecture was at every SEN location there was one parallel DCN router kept which was running on a different fiber. In case of any fiber cut or what we call as in-band connectivity, there was access available through out-of-band connectivity, and that was riding on DCN network. In SEN, you can currently also see that there are DCN routers available through which you can log into the SEN router. Okay, and there is National DCN, which connects the inter-circle DCN connectivity. If you have any queries, discrepancy in nomenclature, or you want full form or anything, just put it in Q&A, we can later address it. So this is a logical explanation with the help of a block diagram how our entire networks are connected.
अच्छा
Whatever I have mentioned,
मित्र येणार होतं.
IPDCN, IP core, IPCP.
ठीक आहे की मित्र
So basically, your pre-ag and access layer will be connected with the aggregation layer. There are few connectivities where pre-ag is directly connected with core. Then aggregation is also connected with core. Then there is your entire core network of IPSEN. On IPSEN, there will be connectivity or NNI connectivity with IPCP devices. IPCP devices we have seen already. What could be the possible connectivities? There is a possibility that STP router is connected with SEN as well as FLDS. There will be packet core connectivity which is connected with SEN as well as FLDS. MPBN network. You might have seen that there is a connectivity between SAR to R4, SAR to MBR router. So your core SEN is connected with IPCP as well as your FLDS or NLD is also connected with IPCP. When we say NLD is connected with IPCP, that logical connectivity is with NES switches. We have changed the nomenclature. Right now we call it as CAS only. But earlier you might have seen those who know. Okay, there are few jargons which are only known to people who are working on specific to IP core. So just understand logically that your FLDS and NLD is connected with IPCP. Okay, in parallel we have our NGN network which is also connected with SEN and it is connected with FLDS. So if there is an inter-circle voice traffic to be going from Pune to Karnataka, you might see that there is one connectivity NNI link from SEN router to NGN. Then through NGN network, it will again connect with NGN to SEN router, and then there will be a traffic. For IPDCN, it is connected with SEN core also. We have given an out-of-band connectivity to FLDS. NLD or in erstwhile IDR, there is no out-of-band connectivity, there is no DCN connectivity. So this is the basic logical blocks of our network. I tried to cover as simple as possible so that you will get a gist of it. Now, this is the network, but how we are managing the network. So we have built an ecosystem through which we can effectively manage these networks. So what consists of the ecosystem? For network management, we have HP NNM, that is the NNM tool. Then for Huawei devices, we have U2000. For Nokia devices, these are the NMS, which manage the network events. Whatever traps or old events, they are directly transferred to HP NNM. If there is a Huawei device, then it will go to U2000. Nokia devices sends its traps to NSP. Ultimately, there are so many NMS, it will be confusing for us to manage. So what we have done is, we have consolidated these traps and then all together we send these traps to TMIP or VTMIP. Now, those who are monitoring at layer 1, they are aware that there are various OCs for each and every circle. To simplify that, now we have unified console. You are monitoring this in UOC. So this flow, you should be aware, those who are monitoring, if there is a network event, you have not seen alarm in UOC, there are basic checks, whether you have received that alarm in NNM or not. If yes, whether that was in TMIP, yes, it was not in UOC, you should raise it to HP. When the trap is not received from node to NNM itself, there is a possibility that there was network isolation due to which the trap was not sent. After network management, there is performance management. We check the traffic, whether there historical traffic. You can log into the device, you can directly check what is the current traffic. You can check if there are any CRC error increasing, but you cannot check that 24/7, and you cannot draw a you cannot keep a historical log for that manually. For that, we have performance management. We use Sev1 as a tool where we can check all the performance of the nodes. Then for inventory management, we have UIM, and after this UOC, a TMIP, we can see Once the ticket is auto-created, the ticket life cycle starts in HPSM. If the ticket is not auto-created, we can right-click and create a ticket. And even if right-click ticket fails, we can manually put all the fields in HPSM and create a ticket. Other tools which are available in network are SNOP Unified Dashboard, where we can download all the reports, and there are automation servers which are connected for scripting. Now, these are the ecosystem part. Now, what are the protocols that are running into the network from technical point of view? So we are using static routing. We are using ISS as an IGP. It is used in IPSEN. It is also used in FLDS, NLD. In NLD, we have ISIS plus OSPF. Soon, OSPF will be removed and it will come on ISIS. In NGN, we are using OSPF and BGP. In SEN also, we are using IGP as ISIS. And for EGP, we are using BGP. For MPBGP, we are using MPLS. Traffic management, we are using MPLS, TE and RSVP. So just a quick question. If we consider MPLS, do you think any protocol is missing? Just put in chat. If you think that MPLS point of view, there is a protocol missing. LDP, yes. But this is expected from L1. You are an experienced guy. Okay. No issue. So we are using, for signaling MPLS, we can either use with the help of BGP or LDP. Or label distribution, we use LDP as in protocol. So far, if you have any queries, any doubt, directly put it in Q&A so that you will also remember, and later I can also address those queries. Okay. Now, what are the nomenclatures? How we have given names of the device, whatever you are seeing. Okay, most of the people who are already in the network from more than 2 years, now they are expert in understanding these names. Those who are not aware, I'll just briefly tell you. The first 2 characters, this is for circle. Then later 3 characters is for city. Then location. In that city, where exactly that box is put. But if we consider this particular node, okay, this is Maharashtra Circle, Pune City, Kalyani Nagar location. Now this function also, there is a segregation. The first 2 characters are VPN aggregator device. So this is, earlier it was WAG, and this R stands for router. So there is layer plus function. And then there comes number, the make. Right now this model is of Juniper, that's why it's J. Make is Juniper, the model is MX480. So accordingly, whenever you see any host name, you can easily identify, like this is the CAS switch. So S stands for switch, and this is access. This is a core device, Kalyani Nagar CCR. This is ISP node, that is why it is internet aggregation node. Similarly, when we see core SEN nomenclature, you will see this particular part as SAR. When you see any DC gateway nomenclature, you will easily see that this particular part will change. Wherever the function is, that particular part will change. So these devices are 4200, CAS 5 and 6 is 4600. This is core devices MX960 at aggregation layer, whether it is internet aggregation or VPN aggregation. This is MX480 devices. So how these devices are connected in FLDS? Your core device, this Kalyani Nagar CCR 1 and 2 MX960, it will be connected with your VPN aggregator. The IGP protocol will be ISIS. Similarly, your IR will also be connected with core device. Given the condition where enterprise necessity is there, IAR will also be connected with CAS. Or in general, you will always see WAG or WAR is connected with CAS. This architecture is applicable for erstwhile IDEO network as well. So when I say core, you will see right now the entire nomenclature is almost changed. So you will not see anywhere NCR or NER. The nomenclature will always be CCR for core route. For NGN, recently they have changed the nomenclature. You will see NGR. Earlier the nomenclature for NGN was different. Right now they have changed it to NGR. So even from the name, you can clearly identify which network device it is, or at least identify the make and model. So far, if you have any queries, just put in chat. I'll just take a quick look of the comment section. Yes, I mean, BGP-LU is used for IGP reachability. Yes, I have deliberately not taken that into consideration because that will again confuse when I say BGP and BGP-LU. But yes, good point. Those who are the attendees, please make a note of this, of BGP-LU. What it is, at least have a basic understanding about it now. So far I have not seen any questions in Q&A, and poll only consists of 33 people. We have 80 people here. Okay, could you explain the functions once again? You're talking about this function, right? So in FLDS, we are using two types of services. Okay, one is VPN service, other is internet service. Okay, so I believe everyone is aware about the difference between private IP and public IP. Yes, I consider that you are already aware. So on internet, we are using public IP, and to make the reachability, we are using ISP network, so that each and every user can access the internet. Similarly, we are using private IPs for VPN services. When I say VPN services, it consists of L3 VPN. On L3 VPN, L3 VPN is a technology on which we are running multiple services. So one of the services is STP, other service is VoLTE, then packet core. When I say packet core, there are services like, you have heard about GIDIP. You might have seen that your GN link fluctuation, S5, S8, these nomenclature or mails you might have seen. Okay, these are all services which are part of VPN. All these services ride on our VPN aggregator router. What that particularly means is they are running the private IP networks. So that is the function. If we are connecting any ILL customer, it is on the ISP router. So that's IAR. Hope that answers your query. If not, we can take it again at the end, where you can directly unmute and ask me the question. So moving forward. So how is the login flow? Okay. So any user, today when we are logging into the router, okay, what we do is, you are either connected in our SNOC LAN or you will be connecting via VPN. After that, you are logging into VPAM. Once logged into the VPAM, you are logging in .35 or .36 server, which is our SSH server, from where you log into the device. But what is the logic behind it? How that happens? So earlier, I have told you about NMS, PMS, UIM. Okay, there is one more entity here, that is ISER. So you will log into your domain, that is either via LAN or VPN. Then you will launch VPAM. From VPAM, you will go to SSH server. Why essentially SSH server? We have around 17,000 of devices. We cannot individually make routing of each device from our SNOC LAN. So what we have done is we have kept an SSH server through which we can manage these devices, so that you will have to make reachability with only SSH server. From SSH server, how the device is reachable? First thing is it should be ICMP reachable. Once ICMP reachable, the device should be open for SSH. Now, when you SSH into the device, the first thing happens is triple. In the AAA service, first happens is authentication. You are aware that there are few devices where you log in with your core ID, and there are few devices where you log in with your local user. So what is the difference? So basically, we have a server, Cisco ISE server. This is Identity Service Engine. What it does is, if your profile is created in ISE, it will authenticate you as a genuine user. Okay. Once you do an SSH from SSH server to the node, okay, the first request will go to ISE server for authentication. Your username and your password. Once you have put password into the password prompt, your username and password is sent to the ISE server. ISE server checks its database whether this is genuine user. Then it authenticates you and then sends the request to the router. Yes, this is a genuine user. And then you are able to log into the device. Now, by any means, if there is no ICMP reachability between the node and ISE server, then your request will be dropped. Or if there is no AAA configuration in this node, you will not be able to log in to the device with your ISE or AAA credentials. Other possibility, your user is not created for that particular profile. There might be some users who are working in circle. They do not have access for other circle. Or the circle users have only read-only access. When we say there are L1 users, L3 users, so we have segregated their authorization levels. So how that authorization levels are differed, ISE server is doing that differ. So this AAA stands for authentication, authorization, and accounting. Once you try to log in, it will perform an authentication. Yes, you are a genuine user. You will be able to log into the device. Then you try to, spray multiple commands. You just do a question. You have just learned many commands. You start doing question mark and you try to execute commands. That time, again, that request goes to ISE server. That is the authorization function. If you are an L1 user and you are trying to execute a command which is supposed to be run by L3, you will get an error. Either invalid command or unauthorized command. Based on the OEM, the error will vary, or it will simply say invalid command. When you say on Cisco, you'll simply get an invalid command. And after that, the third function, accounting. Whatever you are doing on this router, all these logs are collected in ISE. Hope till this part is clear. Now, coming to UIM, EMS or NMS. This particular three functions, they run with ICMP plus SNMP. Your device reachability should be through with UIM, SEV1, HPNNM, U2000, NSP, whatever it is, it should be through with it. Once it is through, it is absolutely essential that your SNMP connectivity should be up and working fine. The test, what we do, the initial test from this server is called as SNMP walk. We say SNMP walk is okay. That means this router will send data or traps to these servers, or these servers will pull or fetch data by itself. It is segregated with port number, SNMP port 162 and port 161. So just need to keep in mind, because later I'm going to take network faults where this part you will understand. Now, once this ecosystem is also connected with our teammate, like there might be few conditions. Recently, you might have seen that there are high CPU tickets, there are high utilization tickets. So what we have done is we have extended the threshold parameter to teammate. Once that threshold is breached, we are creating tickets. Rest from NMS, I have kept UM at the top because we are not creating tickets from UM. It is purely for inventory management. This is not for any ticket creation as of now. So network management system or this NMS server, they will send the traps. Link is down. That link down trap is sent to TIMIP. It is enriched, and after enrichment, a ticket is created. There are few more details how the ticket is created, after what time the ticket should be created. Right now, we are not going into that. So when we say login or management, when we say login, your device should be reachable from your SSH server so that you can at least put a prompt, and the device should be reachable with ICE. Second thing, if you are trying to log in, your SSH should be open on device and firewall. Mostly very less chances that there is issue in firewall. It should be up on, it should be allowed on SSH. The third thing which I have not written here is access list. If instead of 35 and 36 you are trying to, log into the device using back-to-back router or a random router, you may not get the prompt because we are putting an access list. Only infrastructure IPs are allowed to log into the device. And the other thing, in combination with this, it should be AAA reachable. Then only it will take your AAA passwords. Once, if let's say your ICMP is reachable, your SSH is reachable, and AAA is not reachable, you may be able to log in this device with local password. So first thing, you can check with your AAA ID. Second thing, you can try a local password. Or third thing, you can directly ask Apps Infra team whether your user is locked or expired. If any queries, just put in chat. I'll look at it. And since already, like I said, for the network diagram, this is a logical flow. The routing, forwarding, it will vary as per the network. When I say as per the network, okay, this particular diagram that I have made, this is for all the IPsec IP core devices. For IPCP, those few might have this question in mind that I don't use SSH server for my IPCP node. So what you do is you can directly search that node into VPAM. Now your AAA happens at VPAM. Your user is already created in VPAM. Same user is already created on the node. When these two are matched, then you will be able to log into the device. Now, let's say the password is expired on this device. You will not be able to log in via VPAM to the IPCP node. Or other accounting also happens at VPAM. All the logs are getting captured at the VPAM. So I thought someone will ask that I'm not using 3536 for my packet core or DC gateway node. So your packet core and DC gateway node, that is directly connected with VPAM. So instead of SSH server, your VPAM will come into the picture. For few setups where we had earlier few leaf and spine architecture, we have ICE server reachability also. Those who are already accessing, they are aware, they are logging into the OEM switch, and after that they are using AAA credentials only. So again, your AAA will come into the picture and ICE server will come into the picture. This is a login, just a logical flow. We are not going into details. So coming to the next part, OEMs. So we have various OEMs or different make